So the topic of today's lecture is visualization, and we've already seen a little bit of visualizing in the first lecture when we analyzed the novel Little Women without ever reading it. So we saw that we could answer questions like who is the main character of the book or which pair of characters gets married by just plotting some of the data. And the plot that we looked at was this one here. We saw a cumulative count of character mentions by chapter. So to answer the question, who is the main character, we looked at this plot and saw that this yellow line was growing the fastest, meaning that this character was being mentioned the most. And so we said that Joe is the main character of the book. Which pair of characters gets married in chapter 35? We saw that here we have two lines that are kind of increasing in lockstep at chapter 35. That means these characters are being mentioned simultaneously. So we said that Amy and Laurie, the blue and gray lines, those are the two characters who get married in chapter 35. So the point of this was to demonstrate that visualizing our data is a powerful way to understand what's going on. Here's a very famous visualization from the 1800s. If you've ever studied French or Russian history and you know about Napoleon's march into Russia, you know that it was a total failure, and this kind of demonstrates why. So this plot is famous for several reasons. It's remarkably informative. This line here, this kind of tan line, it shows the position of Napoleon's army as it marches from west to east, but also the size of the army. The width of this band here is proportional to how many people were in the army. So you can see that it's sort of narrowing down here. That's because Napoleon started this march in the winter, and winter in Russia is not very hospitable, and a lot of his people were dying or becoming casualties of just the cold and disease. So you see the size of the army, you see how it's moving. Here you see that a part of it split off to mount another attack. And so you just get the sense that this army is really dwindling in numbers. Eventually it reaches Moscow and is pushed back. And then you can see on the retreat that his army size just is shrinking and shrinking and shrinking. And you can see things like, you can see here I'm going to mispronounce this, the Berezina River right here. They had to cross the river. This was a traumatic event for the army where they had a lot of casualties crossing this river in winter, and you can see just that the army size is halved. Now also on this graph is the temperature, so you can see during the retreat the temperature plunges from 0 degrees on 18th of October down to minus 30 on 6th of December, and you can see from here to here just how hard the army had it. So they started out with 422,000 people, ended up with 10,000 able soldiers. So, like I say, this visualization, though old, is very famous because it includes a lot of pieces of information, and it's very intuitive. It has a striking effect. So I think we've kind of answered the question of why visualize. But just to drive it home, we've worked with tables the last couple of weeks, but tables, especially large tables, can be hard to interpret. You have to kind of dig through them to find the overall trend. Visualizations, on the other hand, are great at presenting trends. So we want to understand, what are the ways that we can look at our data to spot trends. And in this lecture, we're going to look at several. You've probably heard of these before: scatter plots, line graphs, and bar charts. Now, the right choice of visualization is going to depend on the type of data we have. So we're going to go through in today's lecture and look at several different types of data and the right visualization for looking at them. We're also going to see how to actually produce these visualizations using baby pandas. So before we take a look at any one type of visualization, let's lay down some terminology. The first thing is an individual. So we mentioned this actually in the first lecture. An individual is just any person, place, or thing for which data is recorded. So even though the word individual kind of suggests that it's a human person, it doesn't have to be a human person. It's just a thing. It could be a movie in a data set of movies, for instance. A variable is something that is recorded for each individual. Sometimes you may hear this referred to as a feature. That's kind of a machine learning term. Variables can be of different kinds. For instance, a variable can be numerical, and it's numerical if it makes sense to do math or arithmetic with that feature or with that variable. A variable can also be categorical, meaning it falls into one of several categories. So, for example, working with the NBA data set, a numerical variable might be the player's salary. This is a number. I can do arithmetic with it. If the individual is a movie, a variable containing the total amount of money that movie made, that's a numerical variable. Or if my individual is a baby, the variable weight or the variable containing the weight of the baby is a numerical variable. Examples of categorical variables. In the NBA data set, I had a variable or I had a column in that table containing the team that the player played for. That's a categorical variable because there are a finite number of options that that variable must take. If an individual is a person in the census, if the variable is the zip code, this might look like a numerical variable, but it's actually categorical because remember, there's a finite number of choices, a finite number of possibilities for that variable. So if there are certain categories or certain groups that the variable must fall into, that's when we say it's categorical. Another great example of a categorical variable is the genre of a movie. Now, there are other types of variables. Before we move on, I'll just mention, for example, a player's name. That isn't really categorical. It's a string variable. It's just a text variable. But in what follows, we're mostly going to look at just numerical and categorical variables. So today, the types of plots we're going to see are scatter, line, bar, chart, and histograms. A scatter plot is whenever you're plotting numerical versus numerical. A line plot will be a sequential numerical variable, which we'll talk about, versus a numerical. Bar chart will be categorical on the x-axis versus numerical. And a histogram will be a so-called distribution of categorical.